All right, so today we're going to talk about section 2-7, absolute value functions and graphs. Make sure you guys include this header. If you're doing notes for my class, include this header on your paper. It has your name, the teacher, the class, today's date, and the learning objective is to graph absolute value functions. So if I were you, I would be taking these notes on graph paper because otherwise you guys are drawing a lot of graphs. A lot of grids. Okay, you do have to write everything else down, but don't write down this essential understanding. I'm mentioning it so that as we go through, you know what to be keeping an eye out for. So just as the absolute value of x is its distance from 0, the absolute value of f of x, or absolute value of f of x, gives the distance from the line y equals 0, which is that horizontal line that's the y-axis, for each value of f of x. All right, so this I do want you to write on your paper. Absolute value function, I am not even going to have you write the definition of that down because it is a function where x is in an absolute value. And if you cannot get that from just the title itself, then there might be something, we might need to do something different in your learning. The parent function of absolute value looks like f of x equals absolute value x. And I think that's evident when you see this. This is definition enough for absolute value function. So its parent function is just a straight x inside the absolute value. I do want you to have a graph so that you guys and put axis of symmetry and vertex on there. So the graph is a nice V shape. Because when we graph, if you think about the graph of y equals x, it's a straight line with a slope of 1 that continues on down into our third quadrant. But because we have the absolute value applied, everything that was negative previously is now positive. So it just took and put a nice little corner on your line. So normally a y equals x line continues down, but that absolute value pops it back up. All right, so let's graph. This will be fun. How is this graph? So we're going to graph y equals absolute value of x plus 2. And we know, so I'm going to put absolute value. So let's go ahead and put our parent function on our graph. And I'll make the parent function a nice little teal blue. So our parent function has, over here has a slope of -1, 1, and over here has a positive slope of 1, 1. Yeah. All right, and we're gonna, from what we learned yesterday, we're gonna take our function and adding 2 to our entire function, every coordinate that every y value that we had is going to add 2 to it. So here at 0, 0, I'm going to add 2. Let me get my pen. So if I was here at 0, 0 on my parent function, then I'm going to add 1 to that. Okay, so every coordinate that we have here, we're going to increase by 2 until we get our nice V shape that is shifted 2 units And always, absolute value is going to be a straight line. So let's make sure that we're using our rulers and making these lines nice and straight. How is this graph different from the parent function? It is shifted 2 units up from parent function. All right, so the same translation rules that apply to all of our parent functions apply to absolute value. So if we want to shift our graph up, we add it to the absolute value. If we want to shift it down, we subtract it. If we want to move it right, we subtract that value from inside the function. If we want to move it left, we add the value. If we want to stretch it vertically, we multiply the outside by a number bigger than 1. If we want to compress it vertically, we multiply that number, or our function, by our absolute value function by a number between 0 and 1. A reflection about the x-axis is taking our absolute value function and putting a minus sign in front of it. And our reflection about the y-axis is taking our x values and replacing them with negative x. So briefly write these down. All right, so we're going to graph this guy, and I always graph from the inside out. So I look at what's next to my x value. So I look for, do I have a negative x inside my absolute value? No. And I don't have one on the outside either, so I have no reflections. But I do have this minus 2. And if you look, when I have a minus 2, that means I'm going to the right 2 units. So we are going to take an, I am able to do this, but please don't draw this until I tell you. So I am able to take and make a parent function. So I'm going to draw this parent function, and then I'm going to shift it according to what this these values tell me. So I am going to shift this whole thing 2 units to the right. That's what this 2 units to the right, my other right. 2 units to the right. That's what this minus 2 tells me to do. And then I'm going to take that and shift it up 1 unit. So my new graph, y equals absolute value of x minus 2 plus 1, is going to be right here. It's the same as my parent function, just over to the right 2 units, up 1 unit. Okay, so don't write this down, but I think it's important to note, I've already talked about some of this. The right branch of the graph, y equals absolute value x, has a slope of 1, up 1 over 1. The graph of y equals a absolute value of x, as long as a is greater than 0, is a stretch or compression of the graph y equals absolute value of x. Its right branch has a slope of a. So whatever you're multiplying your parent function by, in the absolute value, is going to become your new slope. So if I multiply it by 2, then my new slope on the right-hand side is going to be up 2 over 1. If I multiply it by 4, my new slope on the right-hand side is going to be up 4 over 1. if I multiply it by 1/2, it's going to be f1 over 2. So the slope of your absolute value line changes with whatever multiplier we put on the front. And then the left-hand side is going to reflect that and match the right-hand side to keep our symmetry, because our absolute value is symmetric. Okay, so let's see how that looks. So when I'm putting together this absolute value function, my original absolute value function was, I start at 0 and I go up 1 over 1. This now has a slope where I'm going to be doubling all my outputs, so it's times 2. So I'm going to start at 0 and I'm going to go over 1 up 2. Over 1 up 2. So our new slope of this right-hand branch is going to be 2 over 1. And let me put that on here. So I'm going to start at 0, and it's going to be up 2 over 1. And then on the left-hand side, each of these points is going to be mirrored across the y-axis. And compared to the parent function, this is taller and skinnier. So this is that function. All right, let's see how that applies to negative 2/3 absolute value of x. So we're again going to start right here at the origin. Make it blue. So I'm going to start at the origin. This guy is blue. And I am going to go down 2 over 3. And then each of these coordinates is going to be mirrored around the y-axis. So then I'm going to go down to the left 3. And because I am negative, I am downward facing. And because I am in between 0 and 1, I am squished wider and fatter. I'm being compressed. So this guy is, he is wider and fatter, and he is, since it's negative, it is a downward facing absolute value. Okay. Now we're going to put it all together. So the different possibilities of our absolute value function, here's our general form, is y equals some number a times the quantity absolute value x minus h plus k, where a is going to stretch or compress. The vertex, or the point of my absolute value v shape, is going to be at h comma k, and then the axis of symmetry, it's where everything lines up, is at x equals h. And I'm going to highlight axis of symmetry because that is something we haven't talked about previously. So in this example question, what are the vertex and axis of symmetry for y equals negative 2 absolute value x minus 1 minus 3? And how is y equals absolute value of x transformed? So let's start with the first part of this. So my vertex is located at hk. So this guy is my h, this guy is my k. So our vertex is at, and if you look, it's already minus in the equation, so it's x minus h. So if I already have a minus here, my h is positive. And in here it's plus k, so if I have a minus here, it is actually minus. So I always remember it as, if I'm inside, it's opposite. If I'm outside, it's just the way it is. Same. So my vertex is at 1, negative 3. And my axis of symmetry is x equals whatever our h value is, and it is 1 in this case. So that answers our first part of this question. Our second part is, how is our parent function transformed? So we have it's shifted down. Three units. It is shifted which direction? What is that h? What direction does that x minus 1 shift us? It shifts us right. So it's shifted right 1 unit. And the 2, so it has a vertical stretch of 2. And what does the negative do to that function? It flips it across the x-axis. So all of that happened to our poor little parent function. Tons of stuff. All right, so our next scenario, we have, what is the equation of the absolute value function? So I'm going to start with for our second problem, I'm going to start with our original, and we're just going to replace everything as we see it. So normally we would start here at the origin, but we are shifted to the right 2 units. So to shift right, that takes that h value and makes it 2. We are shifted down 1 unit. So we are going to take that k and make it a minus 1. And we have, is this a stretch or a compress? Is it a stretch or is it a compress? Does it make it taller and longer, or does it make it shorter and fatter? So this one is a really tall, skinny, absolute value function, or is it a short, squatty, fat little guy? He's a short little guy, so he gets to be compressed. So we know our A is going to be between 0 and 1, so we kind of have to figure that one out. And I'm going to do it by finding the slope of this line. So the next point that I have is this coordinate right here, and he goes F1 over 1, 2, 3, 4. So the slope of this line is 1/4. And is he an upside down? Is he a V shape down? Is he facing down? Like a little TP? No, so this A value is positive. So the equation of this line is y equals 1/4 absolute value of the quantity x minus 2 minus 1. And that is all for today.